Okay, for those not here, I don't know whether they will see this recording start from the beginning. Okay, if school open after the 2 weeks holiday, um, when 14 is it? I think 14 June. Okay. If our mid-year exam is immediately after the school open, okay. The mid-year exam, the questions I have set is covered the whole chapter 4. Okay. Before that, I set until 4.1. Okay, since we still have a few weeks to finish up lah. So your mid-year exam is chapter 1 until chapter 4 on. Okay, so if got no questions for the yesterday homework, so today I will go to another subtopic, which is a law of logarithms. Okay, so first of all, I will share. Okay, can see the textbook or not?
Yes, can.
Okay, so let's start. Okay, so use the same books. Okay, this is an index for today. Okay, law of logarithm. Okay, today is 18. Okay, so actually this one is also the last part of the chapters. Okay, other than the applications. Okay, so for this whole chapters, we are learning indices, surds, and the logarithm. So in this indices, surd, we have finished. So now we come to the last part, logarithms. Okay. Okay, so first of all, we want to relate the equation in an index form with the logarithmic form. Okay, and then you got to determine the logarithmic values of a number also. Okay, let us start with this. This one you are very familiar. Okay, this is in index form. Okay. Okay, where a is greater than 0 and then a is not 1. All these I will show you afterwards. Okay, all these are constraints. Okay, and a and x are variables. We can find the value of one variable if the value of the other two variables are given. Okay, here n equals to a to power x. Okay, it's a 3 variable. Okay, if two variables are given, okay, should be no problem for you to find the third variable. Okay, so you look at this 3 example. Okay, you look at this 3 example. Okay, revision a little bit for your indices. Okay, see whether you know how to get the third variable or not if two variables are given. Okay, look at the A. Okay, if 81 is equal to 9 to power of x, okay, then how to find the x? Okay, 81 is equal to 9 to power x. Okay, so you see this is a base 9. The 81 also you can write it into a base 9. So you write 81 as 9 to power of 2. So it's 9 to power x. Okay, and then you follow this one. Okay, these rules. Okay, if the base are the same, you can compare the index. Okay, so if the base is the same, so you compare the index. So therefore x is 2 here. Okay, this is for A. Okay, revision a bit. Okay, now we go to the B. Okay, so this one you see it compared to the n equals to a power x. Okay, the variable that you don't know is here the x. Okay, for the B, okay, 1000 is equal to a to power 3. Okay, if you compare to n equals to a to power x, the variable that you don't know here is the a. Okay, so how to find this? Okay, 1000 is equal to a to power 3. Okay, you can write it as a to power 3 is equal to 1000. Okay, then the 3 move to that side will become, okay, power 1 over 3. Okay, power 1 over 3, it means cube root 1000. Okay, therefore the answer is 10. Okay, this is for B. Okay, how about C? Just now, part A is we let the X be the variable that we're going to find. Part B is we let the A be the variable that we're going to find. So the part C is we let the N be the variable that we're going to find. Okay, so part C, they give an example of this. Okay, this is very simple. So just find 5 to power 3, 5 times 5 times 5. So it's 125. Okay, so if this is in index form, okay, and then two variables are given, so there's no problem for you to get the third variable. Okay, next. Now they throw to you these questions. What do you think? Can you find? Okay, can you find the value of x of the following equations? If you see this one is the same types of this. Okay, the A. Okay, so n equals to a to power x. Okay, n and the a are given, but x is not given. Okay, x is the variable that not given. Okay, but if for this example of this a, this one it can be solved is because the n here you can write it as the same base number as the a. Okay, but here you have the problem when the n you cannot get, you cannot write it as the same base number as the a. Okay, the a here is 2, 4. So the base you can lower down is 2. Okay, but also yet the 50 you can't write it as a 50, you can't write it as the 2 to power of something. This is a problem. Okay, therefore this type of questions you can't solve by using this method. Okay, you can't solve by using this method. Okay, so you have to use other method to solve it. Okay, this is why we learn this logarithms. Okay, after we learn it, learn the logarithm, then we will come back to solve these three problems. Okay, so we continue. Okay, we want to see what is the relation in between this index form and the logarithmic forms. Okay. Okay, we go to this website. Okay, first of all, we want to study the graph for the index form and then for the logarithmic form. Okay, so this is in index form. This is the graph. Okay, y equals to a to power x. Okay, of the fx equal to a to power x. And then this is the graph, okay, in the logarithmic forms where y equals to a log ax. Okay, and then you have a line y equals to x. Okay, if you call the line y equal to x, this is very obvious that fx is the inverse of the gx. Okay, or you can say the gx is the inverse of the fx here. Okay, means the y equals to a to power x. Okay, and the y equal to log ax, both are the inverse of each other. Okay. Okay, now I'm going to drag the cursor of this A. I let the A change. Okay, now current the A is a 2.4. Okay, means this one, the graph actually is y equals to 2.4 power x. Okay, then this graph is actually is y equals to log, okay, the base 2.4 and then x. Okay, now I'm going to drag the cursor for the A, okay, to the left and to the right. Okay, and then see what will happen. Okay, we start with we drag the cursor to the right, let the A increase. Okay, you see the graph. Okay, you see how no matter how the graph move, there is one point that not moving. Do you notice that? how the graph move also, there is one point that actually the graph is not moving. Anyone can tell? One more time. The red color line, there is a one point that is fixed. For the blue color line, there is another point that is fixed, although the A is changing. Anyone can tell the point? For the red color one first. You want tap also can? Okay, I come back here. Still waiting. Oh, I want to call. Oh, someone respond. Okay, Emily say what? Is it the y-intercept and the x-intercept not changing? Okay, very good. Okay, for the red color one is the y-intercept. For the blue color one is the x-intercept. But can you, from the graph, okay, tell me the red color, the y-intercept, what is the coordinate for the y-intercept and what is the coordinate for the x-intercept for the blue one? Anyone? Okay, she is quite near already. Emily is quite near already. Okay, again. Okay. Okay, I don't think Izati is here. Okay, same thing. Siwa, Sophie Lee, and then if not anyone here. But don't want Sheru lah ha, don't want Emelina. Okay, not Emmeline. Who Emily. Emmeline. How to Emmeline? Emmeline. Your name look like same. Okay, the red one is 0, 1, and then the blue one is 1, 0. Okay, very good. Okay, so I give you 1 mark here. Okay, can see or not? What's she trying to say? Okay, so here, this point remain unchanged. I don't know whether you can see my cursor or not. Okay, this is 0, 1. Okay, for the red color is 0, 1. Okay, then for the blue color one is a 1, 0. These 2 points remain unchanged, no matter how the A changes. Okay, so next I'm going to drag the A to value 1. Okay, we will see what will happen. Okay, now it's 2.5. Okay, 1.4, 1.3, 1. Okay, when A is 1, okay, we'll see what will happen. You can see the blue color line no more, disappear. Okay, so there is no log base 1 x. Okay, so it does not exist for this graph. Okay, mean does not exist for this log also. Okay, but how about fx, the red color one? Okay, it become a straight line. Okay, because the A now is 1. Okay, 1 to power of anything also is still 1. Therefore, this line become y equals 1. Okay, so it become a horizontal line. Okay, this is why just now we say that A is not equal to 1. Okay, we come back to the textbook. Okay, a very beginning here. Okay, you see how we define it? Okay, A is not equal to 1 here. A is not equal to 1. Okay, this is why we put this constraint. Okay, because when y is equal to 1, for the log does not exist, and then for the index form, there is I mean we can say there's no meaning of it lah. Okay, it become a straight line. It become y equals to 1. No? Okay, so there's no we can say there's no meaning of it. No? Okay. Okay, then I want to drag the cursor A to negative value. Okay, I want to see this. I want to see this. What is going to happen? Okay. Okay, this is still positive. Okay, this is 0. Okay, when it's 0, also the same thing. You can see there's no meaning of it. Okay, you can see the red color one straight away disappear. Okay, because it's at the 0. Actually, it's at the dot lah, one dot here, but you can't see anything. Okay, so therefore we don't take 0 also. Okay, we don't take the A is greater than 0. We don't take 0 and the negative value. Okay, how about negative value? Negative value also, you see the blue and the red, can't see anything. Okay, this is why we define it in this way. Okay, A we don't take equal to 1. Okay, and then A also is we got to take greater than 0. Okay, so this one is I prove it through the graph lah. Okay, next, we want to see whether the logarithms are for negative number and 0, the existence, whether you have a logarithm for negative number and 0 or not. Okay, we come back to the graph. Okay, we take like the original one. Okay, this one. Okay, so you see log, you look at the y value. You look at the y value. Okay, 0 here actually it will not touch. Although you can see it like touching, but actually it not touch. The blue color line is like very near to this y-axis, but actually it's not touching the y-axis. So there is no value for the 0. Okay, there's no value. Okay, log means log cannot be 0. Okay, and then log also cannot be negative. Can you see this part? Okay, no negative. Can see my cursor or not? May I know? Someone? On the mic.
Can see.
Can see the cursor moving. Okay, this one means whatever the x value you take, okay, the y value for this blue color graph, you can see, okay, no negative and then not equal to 0. Okay, this is the meaning of there is no negative value and 0 for the logarithm. Okay, logarithm, sorry. Okay, next we want to verify the following statement is true or false. Okay, we want to see whether log A1, okay, means I come back to textbook. Okay, here. Now I'm doing the last part already. This one. Okay, we want to verify the following statement true or false. Okay, we want to see this log A1 is it equal to 0. Okay, log A1, okay, the one here, if you see the graph, okay, log A gx is equal to log AX. Okay, so now the x is 1. Okay, now the x is 1. Okay, we see the y value gx. Okay, x is 1. X is 1 is here. Okay, this one. Okay, this one. Okay, and then the y value is 0. Okay, so this one is correct. This is true. Okay, how about this log AA? Okay, log AA, if you compare to this, now the x is the A. Okay, if here the A is 2.6, let's say I don't want 2.6. 2.6 is a bit difficult. Maybe I put 2. Okay, now A is 2. So I'm looking at x is 2. Only I will get log 2. Okay, log AA. Okay, so when A is 2, x x is 2 and a is 2, you look at the y value. Okay, here is 1. Okay, so it's 1. Okay, so this is also true. Okay, if you are not happy with the log 2, we can try log 3 maybe. Okay, so I adjust the a become 3. Okay, and then I read x at 3. You can see it still go to 1. If you are still not happy, let us try log 4. Okay, now a is 4. Okay, so I read the x is 4. You can see it's still 1. Okay, therefore this one is true. Okay, so these two you got to remember. Okay, so all these I prove through the graph lah. Okay, we go to the next one. Okay, here from the graph, I want to make these conclusions. Okay, y equals to a to power x. I don't write fx, I write y. Okay, this graph, y equals to a to power x. Okay, and then the other graph, which is the blue one, I write also y. The gx, I write y. Okay, log ax. Okay, you can see these two are inverse to each other. Okay, now I want you to see another two graph also is inverse to each other. Okay, wait for a while. Actually, this topic is quite tough lah, quite difficult to understand, but you try lah. Yesterday night also, I'm thinking, how I explain to you so that you can get the comparison and then relate the index form and the logarithmic form. Okay, I will call out the fx drawer. Okay, so first of all, I'm going to draw this. Okay, log y equals to log x. Base is I'm not sure how to put the base. Okay, so log x means base 10 okay. So I want to plot another graph. Okay, now I'm going to plot is x equals to log y. So can you see? One is y equal to log x, the other one is x equal to log y. Okay, we want to see these two graphs, what is the relation in between them. Okay, so same thing, one more line I'm going to plot is y equal to x. Once I plot y equal to x, you know what is my purpose already actually. Okay, I want to show these two actually they are inverse to each other lah. Okay, let us see. Okay, so it's proof. Okay, these two are the inverse of each other. Can see okay, from the graph. Okay, so I go back here to the textbook. Okay, so another conclusions from the fx draw. Okay, I want to make is, okay, first I have this one. Okay, y equals to log x. Okay, the other one I draw is x equals to log y. Okay, these two also are the inverse to each other. Okay, therefore I can say that, okay, these two are the same. Okay, I don't know whether you can see the relation or not. Okay, if I say how to say P and Q are inverse to each other. Okay, then I say that R and Q are inverse to each other. Then I can say that P and R, okay, are the same. Okay, therefore I can say that okay, this one I just write the other way around. Okay, log AY is equal to X is same as Y is equal to A to the power X. Okay, these two are the same. Okay, okay. This is why I have these conclusions. Okay, this one is very, very useful. Okay, you have to always remember this. Okay, change from the index forms to the logarithmic forms or otherwise. Okay, these two this one is very useful when you solve questions. Okay, so this one you have to remember. Okay, so this one you write in your notes. Okay, and then all these constraints also please remember. Okay, this one just now I proved already to you. And then one more that you can write here is n must be greater than 0. Okay, the n must be greater than 0 is from here. Than 0. Just now, this one. Okay, the logarithm for the negative number don't have, and then for the 0 don't have. Okay, so for the logarithm, it must be okay, greater than 0. Okay, so these three constraints you can write. Okay, another one is this. Okay, another one is this. You also this one actually afterwards we can have another rules to help you lah. Okay, but now you look at this. Okay, why you say the log a to power x is equal to x? Okay, you try to change this follow this. Okay, change this into how to say the index form. Okay, I want to see whether it's true or not. Okay, so you see log a n equals to x. Okay, n you keep. This is how always I see n I will keep. Okay, and then this a I move to this side. The base become the base here, and then this x become the power. Okay, so this one is the index form. Okay, so do the same thing to this. Okay, you see the a to power x I keep. Okay, and then the a here, the base I move to this side become the base. Okay, so that is a. Okay, then this one move become the power. Okay, a to power x equal to a to power x. Yes. Okay, therefore you remember this also, log a to power x is equal to x. Okay, so also you can write in your notes. Okay, and then okay, this one. Okay, this one just now we prove it already. This one also we prove it already. Okay, if I using change from the logarithmic form to an index form. Okay, we do one by one. Okay, one you stay. Okay, the a base move to this side become the base a. This one 0 move out become the power. Okay, is a to power 0 equals to 1? A to power 0 equals to 1? Is a to power 0 equals to 1? Okay, means any number, the a is any number to power 0. You can press calculator. 5 to power 0 is 1. 10 to power 0 is 1. 8 to power 0 is still 1. Okay, so this one is correct. Okay, this one also you write in your notes. Okay, how about this? Okay, now I change the logarithmic form to index form. Okay, a stay. Okay, this a as a base come here, become the base here. Okay, and then here the 1 I move out as the power. Okay, is it a to power 1 is a. A to power 1 is a. Okay, 5 to power 1 is 5. Okay, 10 to power 1 is 10. Okay, 20 to power 1 is 20. Okay, so a to power 1 is a. Okay, therefore, this one also is true. Okay, okay then, because of these three constraints, a must be greater than 0, as a not equal to 1, and n must be greater than 0. So all these example, okay, all these example are undefined. Okay, so please pay attention. Again, these three, 1, 2, 3. Okay, so along the way you do the exercise. If you come across to all this, all these are undefined. Okay, so have to remember. See, the a here cannot be 1. Okay, the a here, okay, cannot be 0. Okay, and then the n cannot be 0, cannot be negative. Okay, I circle out all the mistake. Okay, so all these examples are undefined. Okay, this one also you got to pay attention. Okay, we can see this side. Okay, so same thing. You see how to change from the index form into a logarithmic form. Okay, this one you can go through. Okay, so this one I don't go through with you lah. This one actually is from here, from this one. Okay, so you can go to by yourself. Okay, and then this one also. What's the meaning of this? The common logarithm is the logarithm in base 10. Okay, the common. Okay, when you say common logarithm is understood is base 10. Okay, for example, okay, log 10a, you can write as a log a. This is the short form of the log 10. Okay, other base you cannot write in LG. You got to write full for other base, like example base 2. Okay, you got to write log full. Okay, only log 10 you are allowed to write LG. Okay, and then without the 10 also can. Okay, sometimes we write log without the base also. We understand we understand that it's a base 10. Okay, okay, and then we come to here. Okay, what is the meaning of analog? Okay, if you look at this, maybe you are not sure what it try to say lah. Okay, we try to use a calculator okay, to get the value. Okay, wait for a while. I call out my calculator. I'm not sure whether I know how to use this calculator or not. Okay. Okay, I give one example. Let's say we find log 5. Okay, log 5. We press calculator. Log, okay, 5. Okay, okay, so the answer is 0.69897. Okay, 0.69897. Okay, and continue. Okay, anti-log means the other way around. Okay, let's say, okay, from the 0.69897, I want to find back the 5. Okay, so you anti-log the 0.69897. Okay, see whether you can get back the 5 or not. Okay, here. Okay, you see this is my answer. So I'm going to anti-log my answer. I see whether I can get back 5. So anti-log is pressing a shift and then log. Okay, so you can see here is a 10 to power x. Okay, I put in the answer. Okay, and then equal. Okay, see, I get back 5. Okay, so log and the anti-log are the brother sister lah. Okay, so okay, this is the meaning of anti-log. Okay. Next, this one nothing. Okay, for this, if you want, this one is my zaman during my time the calculator is not so advanced. We don't use the calculator to just now, like you see what I press the calculator so fast I can get the answer. Okay, so during my time we have a table, okay, to find the logarithms. Okay, so if you are interested to see the table, you look at this link lah. Okay, so but I don't want to go through with you. Okay, because now we are using calculator, we no more using the table. Okay, okay. Then next, this one I will skip. This is more or less the same as just now. You can see the how to say, the graph here. Okay, they are inverse to each other. Okay, this one nothing. Okay, so straight away we go to some example. Okay, so first of all, okay, convert this 2 to power 4 equals to 16 in to logarithmic form. Okay, so very simple. Okay, so the base here, okay, become the base of the log. Okay, and then the index will become the answer. Okay, and then 16 is here. Okay. Okay, second example. Okay, the other way around, from the logarithmic forms, okay, change to index form. Okay, so always I will write in this way actually. I will write 27th day. Okay, and then 3 move to this side become the base. Okay, and then this one move up become the power. Okay, okay, so this is what I'm going to write. Okay, okay, how about this? Find the value of each of the following. Okay, this one very simple actually. Okay, so all base 10, huh? Base 10, you just press calculator. Right. Call out my calculator, huh? Okay, so you see the first one. Okay, log 7, you just press log 7. Here you see the same thing, huh? They don't write the base. This is base 10. Okay, log 7. So other base, huh? You cannot directly use calculator. You got to make some adjustment before you use a calculator. Okay, so log 7, this is the answer. Okay, 4 significant figures are there. Okay, 4 significant figures. So 5, 4, sorry, 8, 4, 5, 1. Okay, when you round off. Okay, next. Okay, log 79. Okay, so log 79. Okay, this is the answer. Okay, they give even 4 decimal places. This is 5 significant figures already. Okay, but at least 4 significant figures. Okay, then one more. Okay, this one 3 over 4 power 3. Okay, so you expand first. So 3 to power 3 is 27. 4 to power 3 is 64. Okay, then how you press? Okay, log 27 over 64. Okay, and then cross backward. Oh, no. Uh-oh. Okay, again, log. I'm not good in using this calculator. 64. I think I had to come out, close bracket. Okay, so this is the answer. Okay, the next one, this one I will skip. The example 22, I will skip because afterwards when you learn some law, that one is even easier. Okay, okay, now we go to example 23. Okay, so how to do this? Determine the value of x if log 5x is equal to 3. Okay, so you see, log 5x equals to 3. From here to here, they use from the logarithm forms convert into an index form. Okay, so x you keep, okay, the 5 you go here become the base, and then the 3 move up to become the power. Okay, so very fast. X is 5 to power 3, 5 to power 3 is 125. Okay, same as this. Okay, why you keep the 3 move to the side become the base, and then 4 move up become the power. 3 to power 4 is 81. Okay, that's why I say it's very useful. Okay, okay, for the converting in between the logarithmic form into the index form. Okay. Okay, one more example. Okay, determine the value of the each of following. Okay, find the analog. Okay, so sorry, antilog, not analog, antilog. Okay, so antilog is very simple. You just press shift, okay, log, okay, and then 0.1456. Okay, then answer. Okay, the other one the same thing, huh? Okay, so now still got 15 minutes more. Huh? Okay, I want to go to one more. Okay, so the homework for this exercise, all are simple questions. Okay, you just don't do these 3 questions. Okay, this is actually something like the just now the example 22. I didn't go through. Okay, these 3 questions after when you learn the next one, then you can do. Okay, maybe if I finish this, then I can cancel it. Then you can do. Okay, by using this method. Okay, there are 3 laws here. Okay, 3 basic laws of logarithms. Okay, so this one you have to copy. Okay, x, y, and a, x, and y are positive, and then same thing, the a cannot be 1. Okay, so the first one we call it product rule, product law. Second one is a division law, and then power law. Okay, look at the products law. Okay, why you call it products law is because here this is time, x times y. Okay, for this you can write it in this way. Okay, break it into 2 lots. Okay, with the same base. and then in between is plus. Okay, for times or multiply or product loss. Okay, division law here is divide. Okay, for divide the same thing, you can break it into become 2 log, and then in between is minus. Just now product loss is plus, now division law is minus. Okay, next power law is you can move the power here in front. Okay, this one we call it power law. Okay, so now it will become n times log ax. Okay, so these three have to remember. Okay, and then it's very useful. Okay, when you solve the questions. Okay, so example, I come back here. I'm going to use a power law before I prove it. I don't know whether I have got time to prove it or not. If I got no time to prove it, you'll just proceed with the exercise. Then, you know, when next lesson, I will prove it. Okay. I don't like to use this method actually. Okay, you can use this method also, but I want to use the power law methods. Okay, if you look at this method, I can go through with you also. Okay, same thing. This is logarithmic form. It changed to index form. Okay, so 625 keep. Okay, and then 5 become the base, and then x become the power. Okay, now you have to think of a 625 is 5 to power of what? Okay, so you try and error. Okay, you find out 625 actually 5 to power 4. Okay, so 5 and 5 the same base, therefore x is equal to 4. Okay, this is one way of doing it. Okay, another way of doing it. Okay, log 5. Okay, same thing, the 6 to 5, you know this is a 5 to power 4. So you write 5 to power 4. Okay, then I use the power law. Okay, the power can drag in front. Okay, so 4, I drag in front, log 5, 5. Okay, log 5, 5 is what? Anyone want to give me answer? Log 5, 5 is what? Siwa? Sophie Lee? Okay, Sophie Lee say 1. Okay, thank you, Sophie Lee. Okay, why log 5, 5 is 1? Just now you have learned. Okay, we come back here. Okay, can you see this? This one you have learned. Log AA is 1. Okay, so log 5, 5 is 1. Okay, so very simple. 4 times 1, then you get 4. Okay, so now you can solve all this problem already. Okay, okay, you can choose which method you like. Okay, so these 3 questions also you do. Okay, means do all for this exercise. Okay, I continue. Okay, this part actually is a proof. Okay, this part. Okay, how they prove these 3 law by using this your index law. Your index law. Okay, I think I can leave it to you lah. Okay, this one I leave it to you. Maybe I prove the first one for you, then the B and C you can go through by yourself. Okay, this one, x times y. Okay, first of all, you let the x is this, a to power p, y is this, a to power q. Okay, and then you write this into the logarithmic form. Okay, then you write this into the logarithmic form. Okay, so now we start. Okay, we start with x times y. Okay, so it's a to power p times a to power q. You replace the x with a to power p. You replace the y with a to power q. Okay, after that, from here to here, this one you are using the index law. Okay, if the base is the same and then in between is multiply, you can add up the index, okay, and with the same base. Okay, now what you're going to do is this and this. Okay, I write here, xy is equal to a power p plus q. This is in index form. Write it into a logarithmic form. Okay, so you see the a is the base, this is the base. Okay, this one is the power, become the p plus q, the answer. Okay, and then log axy. Okay, so change into a logarithmic form. Okay, then come to here, what is p? P is log ax. What is q? Q is log ay. Okay, therefore is proven for the first law, the product's law. Okay, so these three I want you to copy. Okay, it's because in case the question asks you to prove the law, you know what to do. Okay, so this part is very important. Okay, how do you start? This part is very important. And then followed by this, how do you prove the law? So this one I want you to copy. Okay. Now we go to the example. How we going to apply this three law? Okay, given log 515 is equal to 1.6826. Log 54 0.8614. Okay, determine the value of each of the following. Okay, so means this one I cannot press calculator, you know. I have to make use of this and this. Okay, so now the number that I'm going to concentrate is 15 and the 4. And one more number, actually very important, is the base, log 5. Because log 5, you know, is 1. Okay, so there are three numbers that I'm going to concentrate with is 15, 4, and 5. Okay, 60, the first one. How I'm going to manipulate the 60, you know, play with the three number here, 15, 4, and 5. Okay, so you see the answer. Okay, you got to think of lah, okay, so 60 actually is 15 times 4. Okay, so next, this is times, so I'm going to use product law. Okay, I break it into two logs. Okay, so one is a log 515 and then the other one is log 54. Here is a multiply product laws, so here is plus. Okay, when you come to here, log 515 is what? 1.6626. This one you replace with 1.6626. Log 54 is what? 0.8614. You replace it 0.8614 and then you find the answer. Okay? Okay, this is for A. Now we look at B. Okay, think of the 12. Okay, how we play with the 12? Okay, you only have 15, 4, and the 5. Okay, you see the answer? Okay, 60 divided by 5. Oh, 60, you see, 60. After when you get this answer already, they make use of this. Okay, 60. Actually, this log 560 is come from the answer from the A. Okay, if got no this part, if got no A, then you got to know the 12 actually is 15 times 4 divided by 5. You kena pandai-pandai. Okay. So now we see, okay, 60 divided by 5. 60 divided by 5. You are going to use the division law. Okay, divide, break into become 2 log. So here in between is minus. Okay, then, okay, log 560 is from the part A answer. Okay, log 55 is 1. Okay, then you get the answer. Next, 100. Okay, so how? 100. 100, you write it as a 25 times 4. 25, you can write it as a 5 to power 2. Okay, so before that, times here become plus. Okay, when you break into two log. Okay, after that, the 25, you can write it as a 5 to power 2. The 2, okay, the third law, okay, power law. You can drag it in front, so become 2 log 55. Log 55 is 1, okay? Log 54 is 0.8614. Okay, you replace with it, and then you can find the answer. Okay, this is how you make use of these three laws. Okay, one more example. Okay, find the value of each of following without using a calculator. Okay, how to do? Okay, so we're going to apply that three law. Okay, so now you see, base are the same. Okay, log 5 minus log 5. Okay, the other way come back to the how to say division law. Okay, just now is from divide, you break into two log, okay, with the minus. Now with the two log with the minus, you can combine it, okay, become one log with the divide. Okay, I don't know whether you can get it or not. Okay, just now is log, okay, divide, okay, is you break into two log, okay, division log. Now it's the other way around. From here you join back, okay, become one log, and then it's divide. Okay, so this is what you get. Okay, and then 750 divided by 6, okay, simplify it, 125. Okay, next step, okay, 125 write as 5 to power 3. Okay, then you use power law, drag the 3 in front. Okay, log 5 is 1, and you'll get your answer. 3 times 1 is 3. Okay, look at B. Okay, B, the same thing. Okay, you have a log in between is plus and minus, so combine it becomes single log. Okay, so when you see plus, remember is times. Okay, when you see minus, remember is divide. Okay, but first of all, before that, the 2 here, move back. Okay, just now you always use the power law, the power move down, right? Now move back. Okay, if not, you cannot join. Okay, after you move back, this is what you get. Only you join them up. Okay, you see, this is plus, you become times. This is minus, you become divide. Now become one log only. Okay, then this part, you just use calculator, you get 27. Okay, then you proceed. 27 as 3 to the power 3. Then same thing, the 3 move in front. Okay, log 3 is 1. 3 times 1 is 3. Okay. Any question to ask? Okay, this is another homework. Okay, so 2 exercises. No question? Okay, Sophie, I will give you 1 mark. Okay, if no questions, then wait, I will stop recording.